Okay, this is my first problem. It's from the Chapter 4 test, and it's problem number 5. Assume that you've applied for 2 scholarships, a merit scholarship, which will be represented by M, and an athletic scholarship, which will be represented by A. The probability that you will receive an athletic scholarship is 0.18. So probability of A equals 0.18. The probability of receiving both scholarships is 0.11. That is an intersection. So that is P, M, upside down U, A equals 0.11. The probability of getting at least one of the scholarships is 0.3, and that's a union. So that's P, M, U, A equals 0.3. Now, the first question is, what is the probability that you will receive a merit scholarship? So this is, I use the addition equation for this. And basically I'm just going to solve for P of M, because the addition to find a union equals P M union A equals the probability of M plus the probability of A minus the probability of the intersection. Now we already know these 3 values, so I'm going to solve for this. So I'm going to plug in the values. P M U A equals 0.3. 0.3 equals P of M, which we're solving for, plus 0.18, that's the probability of A, minus the intersection, which is 0.11. So if I add 0.11 on both sides, and I also subtract 0.18 on both sides, I'll end up with 0.23. So probability of M, the probability that you'll receive a merit scholarship, is 0.23 or 23%. Okay, B. It's asking me if events A and M are mutually exclusive. Why or why not? I would say that they are not mutually exclusive, because mutually exclusive means it's impossible to be one and the other, but it is possible to be athletic and academically strong at the same time, so they are not mutually exclusive. C, it's asking me a conditional. It's going to ask me, are the 2 events A and M independent? Explain using probability. Oh wait, no, sorry, that's D, sorry, C. So, it's asking me if they're independent. So there's a rule to find out if something's independent. And basically, it is independent if the intersection is equal to both of the probabilities multiplied together. So let's see. The intersection of those guys equals 0.11. And if I multiplied the 2 probabilities together, which would be 0.23 times 0.18, it would equal 0.0414. 0.11 does not equal 0.0414, so they are not independent. Okay, now for D, which is the conditional one. What is the probability of receiving the athletic scholarship given that you have been awarded the merit scholarship? So that is the probability of athletic, A, given M. The formula for that is the intersection over the probability of what the given is, which is M. So that would equal 0.11 over 0.23. Those are the values of the intersection, the probability of M. And that ends up equaling 0.4723. So the probability of A given M equals 0.4723. And finally, the last part is, what's the probability of M given A? It says, What's the probability of receiving the merit scholarship given that you have been awarded the athletic scholarship? So once again, it's the probability of the intersection. I'm just going to write it the other way, but it's the same value over the probability of the athletic scholarship because that is the given. Okay, so that equals 0.11 over 0.18, which equals 0.6111. So the probability of M given A equals 0.6111. And that's my first problem.